Okay, what we're going to do now is we're going to start in section 5.3, part 1 video. And so what I want to do first is I want to start out with the definition. And as I oftentimes do with you, when I start this definition, you pause as I read this definition at any point so that you can write this definition down. So write this down and you pause it wherever you need to get this whole definition. The definition that I want to define for you is what we call a polynomial. So here's the definition. A polynomial is a number or letter or numbers and letters with positive exponents only that is added, subtracted, and or multiplied together. Okay, so that's what a polynomial is. Okay, you should have it written down. So let me break it down a little bit at a time. It says a polynomial is a number. So any number, 5, 8, 3/5, 2/3, -11, 0, any number, by definition, is a polynomial. Now, when I see the number 7, do I call it a polynomial? No, I don't. But according to the definition of a polynomial, any number is a polynomial. Now, I already said a polynomial is a number or a letter. So that means X, Y, P, Z, M, R. Any letter is a polynomial. But it keeps going. It's a number, or it's a letter, or it's numbers and letters, variables, with exponents, so you can have exponents. But if you'll notice, I said positive exponents. So a polynomial, your variables cannot have negative exponents on it. So like x to the -3 or xy to the -2. You will never see a negative exponent in a polynomial. You can have exponents, but not negative exponents. So a lot of the problems that you looked at in 5.1 and 5.2, particularly 5.2, but a lot of them in 5.1 also were not polynomials because they had negative exponents. So it can be numbers or letters, or numbers and letters with exponents, positive, and you can add them, subtract them, or multiply them together. So notice the operation that I left out, division. So there's two things that you cannot have in a polynomial. You can't have negative exponents, and you can't have division where you've got letters in the bottom. Those are the two things you can't have. So what I want to do is I'm going to put this up. And as I typically ask you to do, I'm going to ask you to pause the video okay? Pause it now and write this down. Pause it now. Okay, you should have those written down. Now I'm going to slide this up. I want you to pause it again when I tell you to. Okay, pause it again and pick up where you left off. Okay, so you should now have in your notes this whole column right here, every bit of this. If you missed any, back up the video and make sure you copy all of these down. Okay, so here's the question, or here's why I want you to write these down. I want us to look at these and see which of these up here is a polynomial. So 5, is it a polynomial? Yes. -2/3, is it a polynomial? Yes. X, is it a polynomial? Yes. Yes. 5x squared, That's 5 times x squared. We said you can multiply numbers and letters, and you can add them and subtract them, as long as the exponent's positive. That's a polynomial. This is a polynomial. This, right here, 5 times this times that. That is a polynomial. Positive exponents only. Okay, this one. Polynomial, yes. Polynomial, yes. Numbers and letters added, subtracted, or multiplied together, and the exponents on your variables have to be positive. Polynomial, yes. Now, I'll give you 2 quick examples of something that's not a polynomial. This one. This one's not a polynomial because of this. This one is not a polynomial because you're dividing by that letter there. So that's 2 examples of things that are not polynomials. Okay. Now, let me give you 3 other quick definitions if you want to write these down. Whenever a polynomial has a certain number of terms in it, we give them a special name. For instance, if a polynomial only has 1 term in it, it's called a monomial. Mono meaning 1. If a polynomial has 2 terms in it, it's called a binomial. If a polynomial has 3 terms in it, it's a trinomial. So a monomial, a binomial, and a trinomial are all polynomials, but that's a better name because not only does it tell you what it looks like, it tells you how many terms it has in it. Now, once we get to 4 or more, we just call it a polynomial. So let's slide back up and look at this one. So for instance, every one of these you're looking at right here. Polynomial, yes, but more specifically, monomial. So you wouldn't be wrong if you call that a polynomial, but the better name is monomial. Monomial, monomial, monomial. Now, this is 1 term. Remember we talked about how multiplication earlier in one of our videos? Multiplication is like glue. It holds it together. So this is 1 term, monomial. 1 term, monomial. 1 term, monomial, because it's all multiplication. So that is 1 term there, monomial. Now, this one is a binomial. Remember that plus signs and the minus signs breaks the individual terms up. So this is 2 terms. This is the first one. This is the second one. There's the break. So that's a binomial. This one is a trinomial. This one is a polynomial, but it has 5 terms in it. 1, 2, 3, 4, 5. So we just give it the name polynomial. Now, you say, well, this is a monomial. No, this is not a monomial because it's not a polynomial to begin with. Once again, to be a monomial, a binomial, or a trinomial, it has to be a polynomial to begin with. Neither one of these are. Okay, so now let me give you another definition. Write this definition right here down. It's called the degree. Underline degree. Pause the video as you need to. The degree of a polynomial in one variable is the highest exponent on that variable in the polynomial. Okay, so you pause that and get that note written down. All right, so the degree. Let's talk about degree. First, it says the degree of a polynomial in one variable. So, whenever we have a polynomial that has more than one variable in it, like this one right here, how many letters do you see in this monomial? You see 2 letters. What are they? X's and Y's. I would never ask you the degree of this. We only talk about the degree of a polynomial if it has only 1 letter, never 2 letters. Now that's a polynomial, but I would not ask you the degree of it. All right, so what's the degree of a polynomial? It's the biggest power, biggest exponent on your variable that's in that problem. So for instance, right here, this polynomial, what is the degree of this polynomial? It's the biggest exponent on your variable. So the degree of this entire polynomial is 4. All right, what's the degree of this one? The degree is 5. What is this called? It's a trinomial. Trinomial, 5th degree. Binomial, 4th degree. Monomial, we don't talk about degree in that one. Monomial, degree 5. Monomial, degree 2. It's the highest exponent on your variable. Monomial, degree 1. Monomial, degree 1. Now, this is a monomial and this is a monomial, but the degree to both of these are 0 because there's no letters in that problem. So monomial, one term, but degree 0. One term, degree 0. One term, degree 1. Okay, so that's what a polynomial is, and that's how you tell what the degree of a polynomial is. Okay, now what I want to do is I want to talk to you about something else, and it's this: naming a polynomial. For instance, you don't have to write these down. If I ask you this one right here, let me slide that over so you got all of it. Okay. If I ask you right here, 3x plus 7, is this a polynomial? Yes. Is this one over here? Yes. All right. What kind of polynomial is this? It's a binomial. What's the degree? 1. This is a trinomial, degree 2. Now, suppose I told you this. Suppose I told you I want you to take the number 5 and plug it in place for x. So in other words, suppose I told you plug 5 in x's place and I want you to work the problem out and tell me what answer you get. The first question that you should ask me is this: well, there's 2 polynomials here. Which one do you want me to plug it into? Because see, if you put 5 over here and you work this out, you don't get the same thing as if you put 5 over here and work this out. So for that reason, what we do a lot of times in algebra is, particularly if we're dealing with multiple polynomials in one problem, is we give polynomials names. Now, why name a polynomial? Well, it'd be the same reason, like if I was standing in this classroom and I walk in and there's only one person here, and I said, if you would, please come here just for a second, you clearly know who I'm talking to. But if I come in and there was a group of you in the back of this classroom and there was 10 or 15 of you and I only wanted one of you, how would I identify you from the rest of everybody else? I would call your name. And I would say, hey, John, would you come here? So the purpose in naming something is to identify it or distinguish it from the others. So what I want to do is I want to show you how we name a polynomial. Now, you will never have to name a polynomial yourself. Polynomial will always be named for you. But let me show you anyway. You don't have to write this down. All right, so let's suppose I wanted to give this polynomial, suppose I wanted to give this thing right here a name. What we typically do when we name a polynomial is we put an equal sign in front of it and we put the name out here. So the name of it's going to go out here. Now, when we name a polynomial, it will always have a first and a last name. It will always have a first and a last name. Now, just like when you're born, your first name is not fixed. Your first name is optional. But when you're born, your last name is fixed. Well, when we name a polynomial, its first name will go here, its last name will go here. We use letters of the alphabet to name a polynomial. We don't name a polynomial like names you and I use. So I'd use 2 letters of the alphabet. Now, a polynomial's last name is always fixed. The last name of the polynomial is always the letter that's in this polynomial. So if you'll look over here, the letter you see is X. So the last name of this polynomial will have to be X. So if this was an M, this would have to be an M. If this was a T, this would have to be a T. Now you say, well, what if there's more than one letter over here? We never name a polynomial in this class. We never name a polynomial that has more than one letter over here. All right. And we typically put that last name in parentheses like this. Now, the first name of the polynomial could be any other letter of the alphabet you want. So you could say A, B, C, D, E, F, G. You could use any letters that you want. One common letter that we use in algebra is the letter P. Now, don't think that P stands for polynomial, but it is the letter that we often use. All right, now, let me write the other one that I had written up here a while ago. Let me use a different one. Let's see. Let's suppose I had this, and I wanted to give it a name. All right, I'm going to give 2 letters. The second letter is fixed. It's Y. Now, if these were X's, I'd put an X here. Now, use any other letter of the alphabet I want to use. Since I used P up here, I'd rather not use P down. I don't want to use P again. But I could use any letter of the alphabet I want. I could call it Q. I could call it T. It does not matter. And again, that's not important to you because it's going to be named for you. Now, when we read this, we put the word of in between these two. That way you won't read it this way. P times X. This is not P times X. The way we read it is P of X. So this polynomial, the first name is P, and it uses the X variable. P of X. T of Y. Or Q of Y. Not Q times Y. Now, here's the reason that's significant. Write these 2 polynomials down now. So pause the video and write these 2 down now. Okay, you should have these 2 written. Now, here's what I want to show you. Go back and show you what I asked a similar question I did a while ago. Suppose I wanted to find f of 2. So write this down, f of 2. Now, here's the importance in having these polynomials named. This polynomial up here is f. It's f of x. This one right here is p of m. Now, let me say again, I could have used x's down here too. So it's not uncommon for different polynomials to use the same letter, but they don't use the same first letter. So if this had been x's, this would be an x. Nothing wrong with that. All right, so here's what this means. Find not f times 2, f of 2. What you do is you go to the f polynomial, which is up here, and whatever is in this parentheses, you're putting it in x's place. So I'm going to come right up here and put a 2 there, a 2 there, and a 2 there. So this goes in the letter's place. This is the polynomial that you're using. So, pause the video now and copy this down. Okay, you should have all this copied. So all I did was I took this 2 and put it here, here, and here. So there it is in red. There it is. There it is. Now remember orders of exponents. You do orders of operations. Do exponents first. So 2 cubed, that has to happen first. 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 4. Then I brought down that, brought this down. Now multiply, 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 and then just add and subtract straight across from left to right, or use your calculator to do that. All right, last example on this video. So suppose I wanted to find P of -1. Now again, this is the question. Now you can't answer this question if I don't give you the polynomial. So you have to be given these in order to answer these questions. Now, how do you find P of -1? That means go to the P polynomial, which is right here, and in place of your letter, which is M, put -1. So I'm going to put -1 here and here. All right, so let me do that. So you can pause the video now and copy that. Okay, so what did I do? I took -1 and I put it here. So it's 5 times -1 cubed plus 3 times another -1, because there's another M, minus 2. Cube the -1. -1 times -1 times -1 is still -1. Plus 3 times -1. So this would be -5. That'd be -3 minus 2, which is -10. But you have to be given the polynomials to answer these questions. Now, I could start all over and give a new problem, and I could completely change this polynomial. I could still use the same name, but I could completely change that polynomial if I go to a new problem. But you have to use those to answer these two questions. Okay, so this concludes section 5.3 video, part 1.